Hello everyone, let's learn about data frames. Data frames enable us to store and analyze tabular data in an efficient way. Series is a single dimensional data structure, whereas data frame is a two-dimensional data structure. Data frames will have rows and columns. Each row and column will be internally represented using pandas series data structure. Just like how we can create a series data structure from a Python dictionary or a Python list, we'll be able to create a data frame data structure from various nested data structure options. I'll be covering 5 different examples. Example 1 is going to enable us to create a data frame from a dictionary of series nested data structure. In this example, I'm creating 2 different series. The first series is getting created from a list of player names. That's going to become the first column within our data frame. The second series is getting created from a list of player scores. That's going to become the second column within our data frame. Recall that I use the from style of import to import data frame. Because of that reason, I'll be able to directly use data frame where D and F are capitalized. I'm typing the parenthesis after that to indicate that I'm invoking constructor function. As an argument, we need to pass the reference to the nested data structure. Since we want to create a data frame from a dictionary of series, I'm going to type empty curly braces. With your cursor in between the curly braces, go ahead and press enter. That will format the code really well for you. I want my key within the dictionary to be string player name. The corresponding value is going to be the series that was created from the list of player names. That will be call1. The second key is going to be the string score, and the corresponding value is going to be call2 series. Let me go ahead and execute this cell. Observe that we are now getting this tabular two-dimensional structure, which is an example of a data frame. Since we have rows and columns within data frames, we'll have 4 different labels associated with a data frame. Those are going to be row index, row integer position, column index, and column integer position. Where is our column information coming from? When your outer data structure is a dictionary, your column information is coming from the values within the key value pairs. Because of that reason, your keys are going to be column index. The first column has column index as player name, and the second column has column index as score. The first column will have column integer position as 0. Second column will have column integer position of 1. Let's talk about row index and row integer position. Where is our row information coming from? That's coming from the inner data structure, which is a series created from a list of values. Recall that when you create a series from a list, your index and integer positions are going to be the exact same, and they're going to come from the index labels from the Python list. Because of that reason, we are ending up with row index and row integer positions of 0, 1, 2, and 3. Let me show you how we can create a data frame from a dictionary of lists. I'm going to copy the code from the previous example. Instead of using call1 series as my value within my key value pair, I'm going to copy paste the list of player names. Let me copy paste the list of player scores instead of call2 variable. That's going to enable us to create the exact same data frame as in the previous example. Observe that with these two options, we don't have flexibility of using meaningful row index. That's because when you use lists, in Python, you don't have flexibility of setting meaningful labels. You're going to have to use the index as labels, which are always going to be 0, 1, 2, 3, etc. We'll be learning how we can set meaningful labels shortly after a couple of examples. Let me first show you how we can create a data frame from a list of lists nested data structure. When you have list as your outer data structure, your inner items are going to become rows within your data frame. This is different when compared to having dictionary as the outer data structure. If you have a dictionary as the outer data structure, your values within the key value pairs will become columns. Why is there a difference in behavior? If you think about it, it makes intuitive sense. Recall that we represent CSV files data using the list of list data structure. Within a CSV file, your row is going to get represented using one of the inner lists. That is why Pandas folks use the list outer data structure representation to take each of the inner items and make them into rows rather than columns. I have a data variable here which is storing a list of list nested data structure. Let's go ahead and create a data frame from it. This time I'm going to pass the data variable as the reference to the data frame constructor function call. Observe that we now end up with meaningless column index and row index. Why is that the case? That's because both our outer data structure and our inner data structure are going to be lists here. So this is the worst possible option to create a data frame without having to set proper column index and row index. We are going to take this example after a couple of examples, and I'm going to show you how you can set the row index and column index properly. Before that, let's go through how to create a data frame from a dictionary of dictionaries. I have a data variable here which is storing two inner dictionaries. Each of my inner dictionaries has the keys as strings, player name, and score. Within the inner dictionary, I'm using the keys as 0, 1, 2, and 3, and the values are going to be player names and player scores correspondingly. I'm going to go ahead and create a data frame from data by passing data as an argument to the data frame constructor function call. Observe that we ended up with the same data frame as in the previous examples where we used dictionary of series and dictionary of lists. Let me show you how you can leverage the fact that dictionaries are flexible with respect to labels to create meaningful row index here. Let me paste this entire example. Instead of using 0, 1, 2, and 3 as the keys within my inner dictionaries, I can use meaningful keys like A, B, C, and D for Alice, Bob, Cindy, and Dan. I'll have to change the keys within the second dictionary from 0 to A, 1 to B, 2 to C, and 3 to D over here. Let's go ahead and execute this updated version of the code. Observe that we are now getting both meaningful row index and meaningful column index. The rows are going to have integer possessions as 0 for Alice, 1 for Bob, 2 for Cindy, and 3 for Dan. Let's now learn how to rename the row index. Actually, sidetracking that a little bit, I want to show you how to create a data frame from a list of dictionaries, which I missed. When you have list as your outer data structure here, once again, you're going to take each of the inner items which are dictionaries to represent rows within your data frame. So let me go ahead and invoke the data frame constructor function call by passing data as argument. That's going to enable us to create the same data frame as in the previous example. This time again, you don't have flexibility of redefining the row index within your nested data structure itself because your outer data structure is going to be less. Now let's go back to learning how we can rename the row index. I'm going to copy paste this worst possible example of a data frame which is going to come from a list of list nested data structure. Let me go ahead and execute the current version of the cell. Observe that we end up with meaningless row and column index because those are coming from the corresponding integer possessions which are coming from the list index labels. You can pass argument to index parameter as part of the data frame constructor function call. The argument is going to be a list of row index. So I'm going to use my list items here as strings A, B, C, and D. How do we set the column index here? Observe that after I executed the updated version of the code, we got meaningful row index. Column index can be set using columns parameter within the data frame constructor function call. Columns parameter is going to take a list of items as argument. I'm going to use the items as player name and score over here, and that's going to enable us to create a meaningful data frame where we are able to properly set the row index using the index parameter and the column index using the columns parameter. The key thing for you to understand with respect to data frames is that if you're dealing with a list, you have inflexibility in terms of the labels that you can get from the nested data structure. So the best possible option for you to create a data frame where you have flexibility would be to use the nested data structure as a dictionary of dictionaries, because you can configure meaningful labels both for the outer key value pairs, which is going to become the column index, and the inner dictionaries key value pairs, which are going to be row index. I'll wrap up this video here. In the next video, we are going to learn how to perform data lookup and slicing using data frames.